Okay, in this problem, we're going to do some descriptive statistics on a sample, and that sample happens to be the values of net inventory, which is beginning inventory plus inventory produced minus ending inventory. And these are the number of items in inventory. And this is finished goods inventory. So when you're making a bunch of stuff and you have to store it, and you store it before you ship it, if you're shipping less because demand is weak, your net inventory might rise unexpectedly, which signals weak demand. If you're shipping more because demand is high, then your net inventory will unexpectedly drop. So net inventory is kind of a proxy for the demand for your product, right? Lots of net inventory, weak demand. Very low net inventory, strong demand, right? The data's at the bottom down here. So I'm going to copy the data to Excel, and I'm copying everything in the table and the phrase down here, submit question. I'll right click, copy, and I'll paste it here in column A. Now, when I paste it, notice what I'm doing here. I'm right clicking and I'm choosing match destination formatting. That gets rid of all the HTML junk. Okay. Now I'll go back up here to see what I need to do. It says after you copy the data, the number 15, right? The value of NI in month 1 of 2018, month 1 of 2018 is 15. And it should be in cell D2, which it is, right? And I'm doing that just because I want you all to have the data in the same spot as me, right? Now, your data is going to be different. So the number you see here might be different than what I see, right? You might see 22 or 30 or even 2 or 1, right? Mine's 15. And so these two numbers match in my problem, 15 and 15, right? Now I want to delete, we're going to use the same simulated data in a future model near the end of the semester. And we'll need month and year, but we don't need it now. So I'm going to delete columns A through C by highlighting it and then pressing and holding the shift button down and then using the right arrow on the keyboard to go to column C. And then I'm going to right click and delete those columns. So I should only have one column left, right? And this is net inventory. Now, the next thing it says I need to do is highlight the numbers in column A and then name this set of 60 cells NI. So in order to do that, I'm going to one click on A2, one click. I'm going to use a shift button and the down arrow. And I'm going to the bottom of the data set, right? Notice this box here. That box says what? You can't see it, so let me do it from the bottom. I'll start from the bottom. Again, I'm going to one click the bottom. I'm going to go up to the top. And notice this box right here. See that? 59 rows by one column, 60 rows by one column, 61 rows by one column. Well, it should say 60R times one column. And if it says that, you can go ahead and type NI here, right? It says in the problem to name this set of cells NI. Go up here where the cursor is, I'm naming that NI, okay? Now to verify that it worked, I'm going to come over here and I'm going to type equal NI. And notice when I type equal NI, it highlights the numbers under the initials NI, see? From cell A2 down to A61. That means I did it right. I'm going to go ahead and delete that by backspacing, right? Now what does it say to do? Copy the table below to your Excel spreadsheet so that the values of the upper limits are in cells E3 to E10. Highlight cells E3 to E10 and name the set of cells bins. So let's go down here. I'm going to grab everything from LL, which stands for lower limit. That's upper limit, frequency, cumulative frequency. I'm going to go down here until I get to like the word, the letter US or U in the word use. I'm going to right click and copy. And I wanted to paste it so that the upper limits are in E3. So I'm going to click on D1, one click, and then right click the mouse button, and then choose format, match destination formatting. Now I can get rid of this. I'm going to come up here and clean this up. Okay. I'm going to move these two down here. I'm going to widen these two columns. Okay. So these numbers here are going to vary from student to student. My lower limits are 6 to 8.375. That's the lower limit of my first interval is 6. The upper limit of my first interval is 8.375. And what I want to do is I want to count the number of these things that are between those two values. And I want to replicate that for each one of these intervals. I notice this is the upper limit of the first interval, but it's the lower limit of the second interval. This is the upper limit of the second interval. It's the lower limit of the third interval, etc., right? Now I can count these by hand, or I can use a command, an Excel command. In order to do that Excel command, I first need to highlight cells F3 to F10. This is where the frequencies are going to go, the counts. I want to highlight those, right? So in order to highlight those, I can click off the table, then I can use the arrow key to place me under the frequency word. Now I want to hold down the shift button and use the down arrow. Okay. And then it says type equal frequency NI, which highlights the observations of NI, comma, bins. Now I'm going to hit Control Shift Enter, and I don't got anything. The reason why I don't got anything is because I forgot on purpose to name this set of numbers. In the problem, it says highlight cells E3 to E10. E3 down to E10, and then name it bins. So I'm naming this set of cells bins. And when I hit enter, what happens to the frequency? That generates the frequencies, right? Because if you look at this, what is it doing? It's taking the thing in the blue box, the stuff in the blue box, it's counting stuff in the blue box that's less than 8.375, but greater than 6, right? In this first up here, right? In the second interval, it's counting the numbers that are between 8.375 and 10.75, and there's 3 of them. Then what is it doing? It's counting the numbers that are between 10.75 and 13.125, and there's 8 of those. And then it's counting the number that are between 13.125 and 15.5, which is 8, and et cetera, right? And there's 2 that are between these 2 values. And it looks like here's one of them. That's less than 8.375, but greater than 6. And then the 7, right? So the 7 is my minimum value. Okay. Now I'm going to type total here. And I want to calculate the total here. Equal, and the way you get the total frequency, which should equal 60, you type equal sum, and then you can click on the 2, and then you hold down the shift button, and you go down until you get to the 9, or the last frequency, right? So you should have sum F3 colon F10. And that just adds up the stuff between F3 and F10. And then you get 60. That's the total. That's the total. Okay. All right. Now the cumulative frequency is what? Well, the cumulative implies that you accumulate stuff, right? So the best way to do this is I'm going to type right here equal sum, and I'm going to use the left arrow to get to this last frequency. And I'm going to hold the shift button down until I get to the first frequency. In my case, 2, right? And when I hit enter, I'm going to get 60, right? What's that saying is this is answering the question, how many in this box over here, in this NI object from 15 all the way down to 16, how many of those things are, well, all 60 of them are less than or equal to 25, right? This right here is asking how many of the stuff over here, how many of the numbers over here in column A are less than or equal to 22.625, right? So in order to get that, we have to sum these four. So the way I'm going to do that is I'm going to modify this formula over here. I want the first cell to be in row 3, right? I'm going to come over here, I'm going to fix F3. And the way I'm going to do that is I'm going to put a dollar sign between the F and the 3. And so I'm going to leave this alone over here, F10. You can see why in a second. when I copy this to the cells above it, the first one's going to be fixed, the other one will float, right? So let me show you. So why is that 51? Because it's only summing the frequencies from the first interval to the second to the last interval, right? Why is this 47? Because it's summing these frequencies only in this box, which it should be, right? Then we got 29, and we got 21. 13 is the sum of 8, 3, and 2. 5 is the sum of 2 and 3, right? So that's our cumulative frequency. Now, if these were percent frequencies, they would add up to 1.00. And this right here would be 1.00 if these were percent frequencies. If these were percent frequencies, this and this would be 100, right? If this be the frequency. Okay. All right, so now we can type these numbers in. 2, I'm going to use the tab button, 2, 3, tab 5, 8, tab 13, 8, tab 21, 8, hit the tab key, 29, and then 18, then hit tab key, 47, hit the tab key again, 4, and 51, and then the last interval, 9, and 60. And I'll enter to see if I got it right. Looks like I did everything right. Okay, cool. All right. Now, we're going to use Excel to compute the descriptive statistics for net investment. Now, before I move on to doing that, what I want to do is right here, right here, I want to do this. I want to highlight a bunch of cells because I need to check for multiple modes. Right? I need to check for multiple modes. So I highlighted a bunch of cells. I'm going to type equal molt dot or node dot molt. This is looking for multiple modes. And then all I got to do is hit NI, right? Because that highlights those 60 cells, right? And I'm going to hold down the Control Shift button in Excel. If I'm using a Mac, I'm going to hold down the Command Shift button and hit Enter. It looks like I got one mode, right? 19. If I had multiple modes, I would have different numbers in here, right? This command, molt mode, looks for multiple modes. And if there's only one mode, it just does a bunch of copies. So let me go ahead and delete that. I know there's only one mode, right? Let me delete that. I'm going to enter 1 here. Okay. Now, if you had multiple modes, you would enter the number of modes, the number of unique modes that you have. You might have 3, you might have 2, or you might have 1. But if you type in something other than 1, what you want to do is you want to take the multiple modes over here. If you have multiple modes, it might look like something like this, right? It might look something like this. This would say you have three modes, right? Three modes, three distinct modes, right? So then you would put three over here, and then you would enter down here in mode the smallest of the modes. In this case, 18. Right? But I only have one mode. Right? If you only have one mode, then um, that's cool. But if you have multiple modes, you can put the number here and then type the smallest of them. Right? And the reason why I do that is because there's really no way to create an algorithm that spits out. It's just really hard to program that in my open math. This program, this problem. In. So I'm going to highlight this column or this table, copy everything in this table, and then something outside the table, like the letter U. Then right click, copy, and then down here I'm going to paste it. I'm going to paste it in B13. Okay? I'm going to widen this. All right. I'm going to delete that. Okay? Now I'm gonna move this column here. I'm gonna move this column over here. I'm gonna copy it and paste it right here. Okay? I'm gonna delete this over here. I'm just moving it over one column. Okay? Now notice what happens when I double click on this. There's a space here, right? There's a space here. If I delete that space, it'll calculate the average net inventory, right? It'll calculate the average net inventory, which is 17.1333, right? Now this one right here, the ones in italicized letters, they have equal signs. Those are just hints on what we need to do, like max minus 10, and then square root, right? The ones with equal signs in front of them, I can execute them. And the way that I execute them is I just delete the space in front of the equal sign, like I'm gonna do right here. Yep. Since I delete that space, it'll find the median of net inventory, which is 18. And then here, I've already checked for multiple modes. So I'm gonna delete. I'm just gonna have equal mode NI, right? It's gonna find the mode, the value that happens the most. And the value that happens the most is 19. Right? The median is 18, the mode is 19. That 19 happens the most. Here's one of it. Here's another one. Right? There's a lot of 19s, right? So the 19 happens the most. 18 is the value that splits the data in half. So half the observations are less than or equal to 18, and half the observations are greater than or equal to 18, right? So that's the median. The mode is the one that happens the most. And since these two numbers are so close together, and the mean is pretty close to them, right? The mean is 17.133, the median is 18, and the mode is 19. You know, I think the data might be pretty symmetrical, right? It's not perfectly symmetrical, but if all three are the same, then the data is really symmetrical. Now to get the standard deviation, notice there's a dot S here. You can do dot S or dot P. Dot P is if you have a really, really extremely large population, or you have the entire population. Or sorry, if you have all the observations, you use dot P. If you're using a sample, and in this class we're going to assume these are all samples, you use dot S. And that gives you the standard deviation of the sample. STDED is the standard deviation. Dot S means of the sample. And we're going to find the standard deviation of NI. Okay. And then we got to find the variance. The variance. And again, use dot S, search the variance of the variance of the sample. Right? We're going to assume sample in this class. And the variance of the sample is 20.76158. Now notice what happens if I square. Notice what happens if I square that number. To square that number is in cell E18. To square that number, I raise E18. This right here is shift 6. It's an arrow pointing up. That means raised to the second power. Notice what happens. Squaring this gives us the sample variance. Okay. So, now the kurtosis. The kurtosis is not really close to zero. A normal distribution, you want kurtosis to be zero. So if you have a kurtosis at zero, that means the top of the distribution is round. Top of the distribution is round. Zero is round on the top, right? A negative kurtosis means it's kind of flat. A positive kurtosis means it's more pointed. It's got a point on the top, right? So large positive value means pointed distribution. Negative number means flat, and zero means round. Zero is a round distribution at top. Right? The skew is kind of close to zero, negative 0.15, and that means that it's, you know, if the skew were zero, you would probably think that the data is symmetrical, right? Or the distribution looks symmetrical. Now the range is the max minus the min. To get the minimum is 7, which makes sense because there's two values in this interval, and one of them is 7, right? The maximum value is 25, right? There's 9 values between 22.625 and 25. There's 9 of them. And the maximum value is 25, which is right here. Right? How many 25s are there? There's 1, 2, 3. There's 3 25s, right? So there's 3 maximums, right? There's 1 minimum. Now the range is the max minus the min. So in order to do that in Excel, you just type equal and then use the arrow key, go down to 25, and then press the minus symbol, and then use the down arrow to go to the minimum, right? So the range is 18, right? Now here's something interesting. If the mean is 17.0000, 17, and the median is 17, and the mode of 17, the standard deviation is 0. That means the sample variance would be 0. The range would be 0. And if all those are the case, then every value here would be 17. Right? If all these values were 17, that'd be 17, that would be 17, that would be 17, this would be 0, that would be 0, and the range would be 0. The minimum would be 17, the maximum would be 17. In other words, there's no variation at all. In other words, it's not a variable, it's a constant. The variable is probably a constant. Okay. Now the sum is, you sum them up, and then the count should be 60, right? When I divide these two here, I get the mean, right? When I divide the sum by the count, 60, I get the mean, right? Now to get the standard error, what I want to do is I'm going to put an equal sign in front of it after I delete the space. And then I want to take the variance, which is right here, and divide that by the count. Okay. So the standard error, which is important in future classes, is found by taking the variance divided by the count and then taking the square root of that. Now, if you have a sample of 1, which we don't, but if you have a sample of 1, notice the standard error and the standard deviation are equal. But we don't have that situation, right? We don't have that. We have a sample. I just wanted to point that out. Okay. So now we need to insert this stuff, right? 17.1. Whoops. 17.123. Okay, good. Now, before I do that, I want to make these all 3 decimal places. Okay, the standard error is 0.588. The median is 10. I can say 18. The mode is 19. The standard deviation is 4.556. I'm using the tab key to advance the cursor. The sample variance is 20.762. The kurtosis isn't zero, it's negative, so it's kind of flat. The distribution is kind of flat, 6.84. The skewness is not zero, it's slightly negative, so it's left skewed, negative 0.154. The range is 18. The minimum is 7. My minimum, yours could be different. My maximum is 25. My sum is 1028. And my count is 60. I'm going to hit enter. And I hope I got all the answers box. Yeah, I got everything correct so far, right? All right, cool. Now, I'm going to use Excel percentile function or command to keep the 50th percentile. So I'm going to copy the 50th percentile. I'm going to put it down here. I'm going to copy the 50th percentile there. And I'm going to copy the second quartile down here. Okay. So then I'm going to use equal percentile.exe. I'm going to copy that and paste it right here. Now, the first thing you want to type in there is NI, right? NI is the array, right? The array of data, the array of observations, right? Net investment, I mean, net inventory, right? And then you want the 50th percentile, and 50 is a percent, so you want to type 50%. So this is going to give the 50th percentile of net inventory. And I hit enter. Notice it is equal to 18. The median is 18. The median splits the data in the lower half and the upper half. The 50th percentile does the same thing. The 50th percentile is the number that defines the top 50%, right? What about the second quartile? Let's copy this blue function into cell and then type NI for net investment inventory, and then copy. We want the second quartile, so we can type a 2, second quartile. We have the first quartile, we have the median value or the 50th percentile, which is the second quartile. Then we have the third quartile, which is also known as the 75th percentile. So the first quartile is the 25th percentile. The second quartile is the median value or the 50th percentile. And the third quartile is the 75th percentile. Just hit enter. So again, these are all equal, right? Which they should be. They should all be equal. They all represent the same thing. It's a synonym for the same thing. Now, what I want to do. Now it says the Z-score when net investment equals 20. So you have to find when net investment equals 20. So I got net investment equal 20 there, right? It equals that value 20 when you subtract off the sample mean. You do that subtraction first, that's in parentheses, and then you divide after you subtract by the standard deviation, right? X bar is the sample mean, S is the sample standard deviation. So I'm going to go up here to, I'm going to go up here and I'm going to type equal parentheses, right? I'm going to click on the 20, right? Because my net inventory is 20. In your part F, you might have 15, NI equal 15. You might have NI equal 14. You might have NI equal 12. My NI is equal to 20 in part F, right? So I need to find the value in column A that equals this value here, right? 20. So in column A, I have a 20 here, right? That matches the 20 here, right? Now I'm going to subtract off the mean. So I'm going to type the minus symbol. And I'm going to click on the mean, right? I'm going to close the parentheses. So I'm going to do the subtraction proof, right? This is 20 minus the sample mean, right? Now the sample mean is in row 14. In my model, the sample mean is in row 14, right? So I'm going to freeze row 14 with a dollar sign between the E and the 14. All right. I want to freeze this row. You're going to see why in a second. And I want to divide that by what? The standard deviation, F. F is the standard deviation. Now, the standard deviation is in row 18 in my model. In row 18 in my model. It might be in a different row in your model, depending on where you copy. I want to put a dollar sign between the E and the 18. Right? Because again, the standard deviation is in row 18 and column E. Right? The mean is in row 14 and column E. Right? And then 20 is in row 11. I mean, row 11 of column A. Right? I'm going to hit enter. Now, I need to reduce this to 3 decimal places. Okay. So my z-score for 20, the z-score for when net inventory is 20. So this is the z-score. Right? I'm going to change the line here. So this is the net. I'm going to change that. So this is the z-score of 20, right? It tells you how many standard deviations 20 is above or below the mean. Well, since the z-score is a positive 0.629, my z-score is a positive 0.629, it implies the net investment for the month that was observed in is 0.629 standard deviations. Now, because it's positive, that means above. Right? Now, if it was negative, if this happened to be negative up here, right? If 20 was below the mean, right? Like, for example, right here. Okay. If this said 14 and this said 14, this would be a negative 688, right? Negative 0.688. And this would be 0.688. Because the negative means below, right? So if this were 14 in my problem, and this were 14, then I'd be here, right? And my z-score would be a negative 0.688, and that applies the net investment for this month, 14, if that were 14. It implies that net investment for this month, 14, is 0.688 standard deviations below the mean. But mine happens to say 20, right? So it's not negative 6.88. Mine happens to be 0.629, right? So my z-score is 0.629, and that means that 20 is 0.629 standard deviations above the mean, right? 20 is in fact above the mean. Yeah, 20 is above the mean. Now it says in column B, compute all of these scores. Well, you got 2 of them computed, right? You get the rest of them, you just drag this up, and then you can drag it down. This is why we had to put the dollar sign in front of the 14. Yeah, freeze that box. And why we had to put dollar sign in front of the 18. We had to freeze that box. We didn't put it here because we want this to float. We want that to float. Right? So these are the z-scores. Notice the z-scores average. Notice the z-score average is 0. Yeah. The average is 0. Why is that? Well, remember what we're doing here with the z-score. We're getting rid of the mean, right? We're taking the mean off of this variable. This is subtracted by 15. This is subtracted by 17.133. This is this 23. First thing we do is subtract off the sample mean, right? So we've taken off the sample mean, which is why the mean of the z-scores is 0, while the mean of the original values is not. The mean of the original value is 17.133. The mean of the z-scores is 0, right? So that's what we're doing. We're standardizing net inventory. When we standardize a variable, the new transformed variable has a mean of 0 and a standard deviation 1. So if you were to calculate the standard deviation of this new variable, it would be 1. Why? Because we've taken the deviations to the mean and we've divided by the standard deviation, right, on each one of these. So we've demeaned it, and then we've divided by the standard deviation, which means the new value, the new z-scores, the transformed NI will have a standard deviation of 1. Okay. And I would say that the z-score is the single most important thing in this part of the class, because it is the basis of, it's the single most important concept, I think, of statistics, because it is the theoretical basis, or the basis of what we call test statistics later on. Okay. The quartiles were the percentile, the 50th percentile, and the second quartile were 18. Here. Okay, we're getting close to 100%. Now we're going to use the z-scores to compute the following percentages. All right, so what I'm going to do here to make this easier, I'm going to click down here, one click down here on cell A65. I'm going to use the up arrow to go to A61. I'm going to hold down the shift button and press the right arrow 1. And then I'm going to use the up arrow on my keyboard to go to the very top. I don't want to include the name. All right. That little box here, the little box that was here, it should say 60R by 2C, right? So I'm going to right click and sort smallest value to largest value. Okay. My smallest value is a 7, and its z-score is a negative 2.234, right? Notice the next value in the sorted list is 8. 8 z-scores a negative 2.004, right? And you got 10. Notice what happens to z-scores as the net inventory rises, the z-score gets less and less negative, right? And the z-score gets really close to 0 where? Around the mean, right? The mean is 17.133. 17 is below the sample mean, right? Just below it, right? Its z-score is a negative 0.0029. So the negative means 17 is below the mean, right? And a z-score close to 0 means 17 is close to the sample mean. Now, as you rise above the mean, what happens? The z-scores go positive, right? The z-scores go positive. Okay, now the next question, I'm going to answer this question first. Percent of net inventories that are within 3 standard deviations of mean. Now, 25 has the z-score of 1.726, right? This is the maximum value for numbers. There are 3 of them. So we have 3 max. Right? The maximum value has a z-score of 1.726. Right? The smallest value has a z-score of negative 2.24. So all of these values are within 3 standard deviations of mean. Right? You don't see 3.15 here. You don't even see 2 right? You see 1.72. So all these values are less than 3 standard deviations from the mean. Up here, you don't see a negative 3.1. You don't see a negative 3.0 up here, right? I see a negative 2.2. So all of my observations, because this number is minus 2.24 and this number is 1.76, all my observations are within 3 standard deviations. So that's 100%. So right here, I'm going to put within 3 standard deviations. I'm going to copy that and put that right here. I'm going to abbreviate that. Change this to 1 standard deviation. 2 standard deviations. Right? So all 60 of them are within 1 standard deviation of mean. Right? So 100%. I'll hit enter. Okay. Now, how many are within 2 standard deviations? Now, when I'm looking at this, all right, 25 z-score is 1.726. That's less than 2. So all of these values here are less than 2 standard deviations, right? If you're looking at the z-score, right? I'm going to go all the way over on the other side. Now, I'm not going to include 7 and 8 in this, right? 8 z-score is negative 2.004. So it's outside of this, right? It's not within 2 standard deviations of mean. 7 z-score is a negative 2.224. It's further from the mean. So what I'm going to do is I'm going to make a red box. I'm going to make a red box. Okay, everything in the red box is within 2 standard deviations of mean because the z-scores are between minus 2 and 2, right? The z-scores are between minus 2 and 2. So how many are within 2 standard deviations of mean? How many of these net inventories? Well, there's a total of 60 and 2 are outside, so 58 are inside, right? So I'm going to come down here and I'm going to type equal 58 divided by 60. Right? So let's do this. Let me change these things. I'm going to add some decimals. Yep. So 96.67% of the net inventories are within 2 standard deviations of mean. Let me hit enter. Okay. And then now I got to do 1 standard deviation, right? For 1 standard deviation, the z-score has got to be between the z-scores have to be between minus 1 and 1, right? So these are my values that are within 1 standard deviation of the mean. Because the z-scores are between minus 1 and 1. So how many are there? Let me go from the bottom. I'll hold down the shift button and I'll use my up key. Right? And then I can use that little box right there. See that little box right here? It says 37R times 1. So there's 37 that are highlighted yellow, right? Let me come down here and I'm going to type equal 37 divided by 60, because it's 60 total, right? So I have 61.67% of net inventories are within 1 standard deviation of mean. I'm going to type that, 61.7. Okay. Now it says we need an ogive and a histogram. So to do the histogram, I want to highlight my upper limit, right? Hold down the shift button. Now notice that my cursor is free, right? It's not inside. So once I'm on that upper limit, I want to hold down the shift button, get all my upper limits of my intervals, and then go over and get my frequency, right? Then I'm going to click on insert, recommended chart. I'm going to pick the clustered column chart. Let's pick it. Okay. Now this isn't a histogram yet because there's a gap here, right? There's a gap here, and what we need to do is close the gap. So I'm going to click on one bar. I'm going to right click on that bar. Let me click off. I want to right click on a bar, and then click Format Data Series. And I want to close the gap to 0%. I want 0% gap width. Okay, so this is now a histogram, right? My histogram is going to look different than yours because I have different data. Right? And this right here is the upper limit of this box, right? This is the interval here, right? This is the upper limit of this corresponds to this line thing that will come down here. This corresponds to this edge. This corresponds to the one that splits this in thirds. This corresponds to here. This corresponds to that value here. So these are the upper limits of these intervals here. Now, one thing we could do here is we could go back and format data series and maybe do like, I don't know, 5%. We can see a gap there, right? So this is an interval. This is the first interval here, with the upper limit being 8.375, right? Yep. So this is 6, and this right here is 8.375. This is 10.75. This is 13.125. This is 15.5, right? That's one way to make a histogram. Now, if you notice, it's not very skewed. It's not very symmetric, is it? It's also kind of flat, right? There's a lot of bars that are roughly, so the flatness of with the exception of that, it's pretty flat, isn't it? With the exception of that, it's pretty flat. So that's why the kurtosis is a negative. Because it's pretty flat, right? It's kind of uniform. It looks more uniform than anything else. Also, the skewness is negative, right? Skewness is negative because you can think of this as the peak of the distribution, and you have a really long left tail. In this tail, if this is the peak of the distribution, you got 1, 2, 3, 4, 5 intervals of data on the left side of the peak. You only have 2 intervals on the right side of the peak, which is why the skewness is negative 0.154, right? So this histogram, the fact that this is not that close to 0, this is kind of close to 0, but this is not very close to 0. That histogram, and the fact that this is not very close to 68%, a normal distribution requires this to be 68%, this to be 95%, and this to be nearly all. 100% is pretty close to nearly all, right? This is pretty close to 95%, but within one standard deviation, it's not very close to 68%. A normal distribution requires this to be 68, 95, and nearly all, or 100%. Right? So this right here makes me doubt normal. This makes me doubt normal. And you're looking at histogram, what happens here? I must have believed my histogram. Yeah. So, oh, there it is. Yeah. So my histogram kind of makes me think not normal. That makes me think not normal. And that makes me think not normal. This right here and this makes me think normal. This makes me kind of think normal. So the evidence is kind of mixed here, right? Also, the fact that these 3 numbers are close together makes me think normal, right? But to look at that, the kurtosis, and that number makes me think it's probably not normal. So again, the evidence is mixed. Now the last thing I do is do an OGI. OGI. It looks like OGIV. I think it's OGI. Okay, the way the OGI works, way to create an OGI, and move the histogram down. And then I'm gonna highlight these two things here: the upper limit and the frequency. And then these aren't the actual correct columns to choose. But I'm going to go to insert. I'm going to choose a scatter plot with straight line. Okay, I'm going to choose scatter plot with straight line. Okay, now this is the wrong ogive. Ogive, right? So what I want to do is I'm gonna make it the right ogive by pulling this. Notice I'm grabbing the right edge of this blue box. I'm gonna hold down my mouse button and slide it to here. Now that is the correct graph for the ogive, and it's not very S-shaped, right? It's not very S-shaped. It's pretty linear, right? That also tells me that this is probably not a normal distribution. It's too linear, right? It should be more like swooping, like swooping in and then going up and then leveling off. To me, it's too flat. So this is the ogive. Okay, that's the ogive. Yeah, so it should be more S-shaped. That's the ogive. I'm gonna put it over here. I got the histogram. The histogram and ogive suggest not normal. And we should have 100%, right? Okay, I'm going to make the next video. I'm going to make a separate video for question 2.